There is a list your machine hands out to websites without ever being asked for it, and it is one of the oldest signals in this entire space. It is the list of fonts installed on your computer, and a site can rebuild a good part of it in the time a page takes to load, without a prompt, without anything visible on screen, and without you ever agreeing to share it. Today I want to explain, defensively and in plain terms, what font fingerprinting is, how detection reads it, and why a signal that sounds this boring is quietly one of the strongest identifiers of browser leaks. For my Cine Esteban, I run real proxy and cloud phone farms, and I test how these browsers handle fingerprinting for a living. So the unglamorous signals like this one are exactly where I spend my time, because they are the ones tools tend to half-fix. I am going to keep this third person and defensive the whole way, how the technique works and how it is defended against. Not a recipe for beating any particular site. And there are no indetectable promises anywhere here. Understanding fonts removes one more contradiction. It does not make anything invisible. It transforms the simplest version of the mechanism, which is enumeration. A script draws a short test string in a font it wants to check for, and then it measures the width and height of the box that text takes up. If that font is installed, the text renders in it and the measurements come out one way. If the font is missing, the browser silently falls back to a default and the box comes out a different size. By comparing those measurements, the script learns whether each font is present. Repeat that across hundreds of candidate fonts, and it has reconstructed a large slice of your installed font list. There is a second, deeper layer to this, and it overlaps with the canvas. Beyond which fonts you have, the exact way your machine draws each glyph, the precise pixels it lays down, varies with your operating system, your font rendering engine, and the hardware underneath. So a site can render text and measure not just the size of the box, but the fine detail of the shapes inside it. That ties font fingerprinting directly into canvas fingerprinting, because a lot of canvas tests are really just drawing text and reading how your particular machine renders it. Fonts leak twice, once as a list and once as rendering behavior. Here is why that list is worth so much to a tracker. Your operating system ships with a base set of fonts, but almost nobody stays on the base set. An Office suite adds its fonts. A design tool adds a pile more. Language packs add scripts for other alphabets. Even some games and applications drop typefaces onto your system. The particular combination of extras you have ended up with is characteristic, and it is stable, because it only changes when you install or remove software. High entropy plus stability is precisely the combination that makes a signal valuable, and the font list has both in abundance. That stability is the whole thing to hold on to, the same way it was with the canvas and with audio. A real machine returns the same font list and the same rendering metrics every single reload, day after day, because your installed software does not change between page loads. A genuine user's font fingerprint sits perfectly still. That is normal and expected, and it is exactly the property a careless spoofing strategy breaks. Break the stability and you have converted a quiet background signal into a bright flag that says something here is being tampered with. Anti-detect tools take one of a few approaches to fonts. Some spoof a fixed plausible font list for the profile, so enumeration always returns the same believable set. Some limit what enumeration can see, restricting the answer to a small standard list. And some add a little noise to the text measurements themselves, so the rendering metrics never read exactly true. Each of these trades off differently between hiding your real machine and looking like an ordinary one. And as always, the difference between them is where the real-world success or failure actually lives. The trap that catches the most setups here is agreement with the platform. Your font list has to match the operating system your profile claims to be. A Windows machine has a recognizable set of Windows fonts. A Mac has its own distinct typefaces, and the two barely overlap. So if a profile reports a Windows user agent, but the font enumeration turns up Mac-only fonts, or the other way around, that is a flat contradiction, and it is the kind detection is specifically built to notice. The fonts have to tell the same story as the platform, the canvas, and the web renderer, not just be present. Then the pay-render noise approach is the one that most often backfires, and it fails for the same reason it failed with audio. If a tool perturbs the text measurements every time a page reads them, it hides the true value, but it destroys stability in the process. picture it from the detector's side. Read the font metrics twice on one page and get two different answers, and no real machine behaves that way because text rendering is deterministic. The same string in the same font measures the same every time. A measurement that shifts between reads is not hidden. It is loudly announcing that something is actively rewriting it. The better behaved approach is a consistent, believable set chosen once. The tool picks one plausible font list for the profile, sized and shaped like a real machine of that kind, and returns that same list stable across every read and reload the way genuine hardware would. And believable matters in both directions. A leaked real list identifies your true machine, but a list that has been stripped down to almost nothing is just as bad because very few real users have a nearly empty font set. A bare machine is rare and anomalous, so trimming too aggressively trades a common fingerprint for a suspicious one. Fonts are never read in isolation, and this is the part people underestimate. A detector can line the font list up against the canvas result, the web renderer string, the reported platform, and the rest of the hardware picture, and check that they all agree. If the fonts have been spoofed to look like one kind of machine, while the canvas rendering or the platform string still points at another, the pieces disagree, and that contradiction scores harder against you than any single value would on its own. A good tool has to keep the whole machine story consistent, and fonts are woven right through the middle of that story. Modern fingerprinting scripts actively hunt for the signature of font spoofing. They read the measurements more than once and check whether they hold still. They look for a font list that is implausibly small or implausibly generic, and they cross-reference the fonts against every other hardware signal for agreement. The well-known open-source consistency tests do exactly this, and they will happily flag a font list that does not match the platform it is supposedly on. The naive defenses have known counters now, and detection has moved on to catching the defense itself rather than simply reading the real device. There is a quieter mistake that undoes everything, and it is the mirror of the noise problem. If a tool hands every one of your profiles the identical spoofed font list, then all those profiles now share one fingerprint at the font layer. You built separate profiles precisely so they would not link together, and a shared font list relinks them anyway, no matter how different their cookies or their proxies are. A good implementation gives each profile its own distinct but stable and plausible set, so the profiles match neither your real machine nor each other. Sameness across your own profiles is every bit as dangerous as instability within one. Mobile complicates this the way it complicates everything else. A real phone ships a fixed system font set and, for the most part, does not let users install extra typefaces. So a genuine mobile font list looks quite different from a desktop one, and it looks different between phone platforms too. A profile that claims to be a phone while enumeration turns up a sprawling desktop font list, complete with Office and design tool typefaces, is the same contradiction wearing mobile clothing. Believable mobile emulation has to reach down to this layer as well, which is one more reason honest mobile profiles are harder to produce than swapping a few reported values. And like every signal, this one drifts. An operating system update can add new default fonts or retire old ones. A browser update can change how text is measured, or a detector can update its checks to catch the current generation of spoofing. A font set that tested perfectly clean last quarter can quietly start disagreeing with the platform it claims. And because none of this is visible from your side, it is easy to keep trusting a profile long after the ground shifted underneath it. This is why fonts, like the canvas, are not a one-time setup step. They are worth rechecking, especially right after any browser or system update lands. Their practical audit is short and worth doing before you trust a profile. Load a public font fingerprint test twice and confirm the list comes back identical both times, not shifting between reads. Confirm the list matches the operating system the profile claims, so a Windows profile shows Windows fonts and a Mac profile shows Mac ones. Confirm it is neither empty nor bizarre, a plausible everyday set rather than a stripped-down husk, and confirm the text rendering agrees with the canvas result. Stable, platform matched, plausible, and consistent with the canvas. Those are the same questions a real detector is quietly asking. Be clear about what getting this right does and does not buy you. A stable, believable, platform-matched font list removes a specific and high-entropy contradiction, and it closes a gap that a surprising number of tools only half handle, because fonts feel boring and rarely make the marketing page. It does not address your behavior, your account history, or how detections shifts over time. And it does not make anything undetectable. It is one more layer made consistent, one more contradiction removed from the pile. That is real value because fonts carry more entropy than most people credit. But it is a piece of the picture, not the whole of it. So the honest takeaway is that font fingerprinting is the old and glamorous signal that quietly does a lot of the identifying work, a list your machine hands out for free, and a rendering behavior that ties straight back into the canvas. The defense is the same discipline as everywhere else. A font set that is stable, plausible, matched to the platform, distinct per profile, and consistent with the rest of the machine, checked by you rather than assumed. Which browsers actually keep the font layer honest under testing, and which ones leak a real list or a giveaway one, is written up hands-on with no undetectable promises anywhere, in the full written reviews and tested pics at antidetectreview.org. If this cleared up a signal you had never thought to check, subscribe, because there is more coming on the quiet layers underneath the ones everybody talks about. See you in the next